Rajeshwari MJ. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Applied Electronics. Today we are dealing with the subject Semiconductor Devices and Integrated Circuit. Let's start with the unit 4, which consists of about charge transfer device. In this topic we are going to know about different types of charge transfer device. Let's know what are the contents that we are going to discuss today. The contents are charge coupled device, that is one of the type of the charge transfer device, and another type is bucket brigade device. The charge coupled device and the bucket brigade device are the two types of charge transfer devices. At the last we are going to know about the applications of these two devices. Let us start with the charge transfer device. What do you mean by charge transfer device? The charge transfer devices are those devices where we are going to remove the charge packets. In the next few slides we are going to discuss about how the charge packets are formed and how these charge packets are transferred from one cell to another. This is a process involved in the charge transfer devices. And in the charge transfer devices there are two types. One is charge coupled devices, another one is bucket brigade devices. These two are classified based on the representation of the pattern of charge transfer. Based on the charge transfer we are classified the charge transfer devices as charge coupled device and bucket brigade device. Let us start with the charge coupled device. The charge coupled device defines the device which is going to convert the light into electronic charge. The device will going to operate as the electronic charge will form with the application of photon. When the photon is applied to the cathode terminal of a semiconductor device, the electron will going to eject from the surface, which will going to produce a charge packets. And this consists of different types, that how we are going different steps, that how these charges will going to flow from one cell to another, we will discuss in further. Then these devices which work on a light, that is what, which is worked on a principle of converting light energy into electronic charges. These electronic charges are digitized and stored as an image file on a computer. This is what defines a charge coupled devices. By the definition we come to know its application. Since this charge packets will going to be saved as image file, we can say that this will going to use in a camera, still cameras technology, and also in telescopic devices. Next, how does a CCD look like? It looks like a silicon wafer. It is actually manufactured same as the other semiconductor devices will going to manufacture. That is we are going to study in the next unit, unit 5, and it is having in the figure that you can observe the silicon wafer, and it consists of 3 CCDs, and these are the assorted the interconnected chips, where this is of about 6 inches. Because of its scientific CCDs are very big, because only a few can be fitted onto a wafer. This is a very costlier devices, and also we need to remember that the silicon wafers are brittle, that is fragile. So, it is very sensitive that we need to take care of the CCD material by when it is handling. And next we move on to basic structure. We know how it physically looks. Now we zoom into it, what is inside it, how it going to work, what are the features, and how the charge will going to transfer from one cell to another. This is how the basic structure. This is a image capturing area. This area is called as image capturing area. Actually this whole box is called as CCD, but this part is divided as a image capturing area, and this is the mask or storage area. Where the image is captured is called as image capturing area, and the image captured is transferred from one cell to another. At the end, these are the masked area where the image are shifted to the shift register and it is transformed to the amplifier. Here it will be still in charge mode. From here to here it will converted from charge to electrical signals, and this is amplified and then it is digitalized, then it is stored as an image file in a computer. This is how the basic structure of a CCD. And from this image you can understand even better how the charge motion. This is a image area exposed to light. This is a part where we are going to expose it to light. This is a small area which is called as a picture, small picture element called as a pixel. This is a small pixel. We also call as a cells, where the charge packets are stored and it is moved from one pixel to another or one cell to another like this, and end it is moved to this serial horizontal register. This is the motion of charge, this is the direction how the charge will be moving, and this is the charge motion in the horizontal register, and then it is fed to the output amplifier. This is a masked area not exposed to light, because this is masked, only this part is called as image area. This is masked and it is not exposed to light. Next, another structure, the CCD structure, where we can observe the semiconductor device. This is a panel view, and this is what we call as a 1 pixel, that is what the rectangle box that appeared in the structure 1. This is a transparent horizontal electrodes that defines the pixels vertically. This vertically we will call it as a pixels. Also this is used to transfer the charge during the readout. When we are going to read out the image, these pixels will be used, and the cross sectional view of this structure will appear like this. Every semiconductor device will going to fabricate on a N type substrate. So, P type substrate. On top of P type substrate, the N type silicon will be there. On top of it, insulating oxide will be there. On top of it, electrode will be there. So, from this structure, it is clearly specifying that the CCDs are made up of MOS, metal oxide semiconductor device, also called as MOS capacitor. So, the CCDs are made up of MOS capacitors, and this is the photo micrograph of a corner of an EEV, that is electronically enhanced vision. This is electronically enhanced vision of CCD. This is how it looks like. This is a image area. This is a serial register where it is a masked one, the serial register where the imaged, the parallel cells are going to drop the charges from here to serial register, and after that the charge packets will going to move through the serial register, and at the end it is read out by an amplifier. Next, we know about the pixels, where the pixels placed in a CCD, about the CCD structure. Now, we going to study about the single pixel, how it works, what are the features of the pixel. The CCD comprises of many pixels and which are made up of MOS, as said as MOS capacitor, and these will allow, this will having the features of receiving a quantity of charges from upstream, that where it is going to, some of the cells we consider as initiative cells, which is directly exposed to light. The very first cells directly exposed to the light, which will going to initiate the process, like when it going to take the light, the electron will going to eject, which will go in turn going to make a charge packets. The initial cells will going to enhance this process by making a charge packets, that is called as a receiving, that receiving cells which have a quantity of taking a charge from the up cells. Once it is initiated, next cell has to take the charge packet from the up cells and it has to give the same charge packet to the down cells, and it has another property that it has to hold it for a quality of time, specific time it has to hold it without losing any data. So, These are the features that a pixel should have. And one more thing, the blooming. From the picture here, this is shows a vertical overflow of a drum structure. This is how the blooming will happen. This is the potential well we called. The electrons, when the photons will going to hit this part, that is a very first p type material, the electrons will come and the electrons in the end region will attract it and forms a potential well like this. This is a maximum charge that is that will be stored in a well. After this, the charges will going to flow to the next cell, and this is the structure. That is how the metal oxide semiconductor capacitor looks. This is N channel, that is the potential well. After ejecting the electron from due to the photons, the potential well is fully filled, and this is the polysilicon gate. This is the photons, this is a p type silicon, the substrate, this is the N channel. Next, according to the image area, exposition of image area, we are classified the CCD as full frame and frame CCD, and last one interline CCD. So, let us learn the first type of CCD is full frame CCD. It specifies that the image area here is full frame. The full frame is exposed to the light. Here it looks like this. This is the masked area where it is black and white color. This is of colored, and this is the exposed area. That is why it is called as full frame. The full frame, the whole frame is exposed for the light. That is why it is called as full frame. This is the output amplifier. This is the CCD serial shift register. This is the parallel CCD shift register, and this is how the pixel looks like. And this is how the charge motion from here to downward it moves, and in the serial register from right to left and to the amplifier. Next we move on to frame transfer. This is another type of CCD where the image area is one frame is masked and another frame is not masked. This is the storage area where image is going to be exposed, light will be exposed to this area. This is the masked area. Here the CCDs are masked by mechanical shutter. Mechanical shutter is used for masking this area. The charge is again moving from here to here. This is how it looks like. The charge packets will flow from top to downwards, and by frame, by each frame wise, whole entire this frame will going to transferred entire to this frame, and again this will going to flow to the serial shift register and to the output amplifier. Next, interline transfer. The name itself indicates it is line. Line will be one whole line will be masked, another line will be an image area. This is how it looks like. This gray color line will indicates the column. The column will indicates the masked area, and the white colored column will indicates the image area. On this we are going to expose the light. So, when this image area is exposed to light, this is how the packets are arranged. Again this packets move to the left side, the masked area, and after this will going to move to the down serial register. This left side it will going to move in the second picture, and in the third one it will going to move downward in the masked area, and it reaches the shift register, the serial shift register, and again it will going to connect to the charge will convert to the electrical signal, and it is fed to the output amplifier. This is how the interline transfer CCD works. Let us have a short break. Welcome back after a short break. Till now we studied about the CCDs and a different type of CCDs. Now we are going to discuss about the functions of CCD. Basic function of CCD have different steps. What are the steps? The very first step is charge generation, and that is by photoelectric effect we are going to generate the charge. The next one is charge collection. Due to the charge collection, the potential well will be formed. The third one is charge transfer. How this collected charge will going to transfer. Last one is charge detection. The sense node will detect the capacitance, how much there will be a capacitance of each cell, that after that it should overflow. For every cell there will be a capacity to hold the charge for a maximum value. After that the blooming, what I said, the blooming will happen, there is a sense node to detect that, after which the maximum charge stored in the potential will transfer to the next cell. These are the four function of a CCD. Next, the very first function is charge generation, that is by photoelectric effect. Before going to photoelectric effect, we need to study the band diagram, the energy band diagram of a semiconductor. We know that the conduction band and valence band are separated by are having a small forbidden gap, and it is having an energy band gap, that is 1.12 electron volt, that is a band energy of a semiconductor 1.12. So, this only small energy is sufficient for a free electron to move from valence band to conduction band. This is we studied from the semiconductor characteristics. So, if we give a small energy for the valence band, that is 1.12 electron volt, the free electrons in the valence band will move to the conduction band. This is what we study from the energy band diagram of a semiconductor. Next, we move on to photoelectric field. The photo means light. Due to the photo light, we are going to make a electric field. So, how we are going to make this? When the light is exposed to the semiconductor, free electrons in the valence band will get energized, will going to absorb this energy and energized and release the free electrons to the conduction band. This is how it will looks. The photon will hit this electron and this will energize and it will move to the valence band. We will get the electrons in the conduction band. So, when the light is applied to the electron in the valence band, this electron will energize due to the absorption of energy from the photon, it will move to the valence band. So, we will get enough free electron in the conduction band for the conduction of electricity. This absorption of light energy and forming a electronic charge from the photons is called as photoelectric effect. Next, potential well. How the potential well is formed? Due to the diffusion process. We know the cross section of a CCD looks like this, the P substrate and the N type material on top of it, this is a insulated silicon dioxide layer, this is a gate. So, when the photon is given, the P type material will have a majority carrier, that is holes will attracted to the N type material, and electrons, the majority carrier N type material will move to the P type material. This process is called diffusion. Due to the diffusion, imbalance concentration is formed and the electric field increases. Due to this, electrical potential increase here in this region. That is why here electrical potential reaches the maximum value. The curve showing here, the region here we will find the electric potential maximum. This is what we can observe from the potential well formation. The potential well is formed due to the electric potential reaches maximum value. Next, we know that the region of maximum potential formed due to the diffusion process. This vertical line indicates the electrical boundary. This will indicates the boundary of a pixel. The horizontal line will indicates from here, if you look here, this as a top view, the vertical line indicates the pixel boundary and the horizontal indicates a channel stop. This is where the channel will going to stop. This is where what we call as potential well formed due to the diffusion is maximum in this region, and if we look from here, this line indicates the boundary of a pixel and this line indicates the boundary of the channel. Next, with another important thing, the charge collection in a CCD. This photon will attract the holes and electrons, makes this electron hole pair. This will go into the, after the electron hole are formed, this pair will attract the electron, forming the charge packets like this. I will show it again how the charge packet is formed. incoming photons will produce electron hole form, and this will attract the electrons in the n type region. This forms the charge packets. First incoming photon will attract the holes here in the p substrate, forming the electron hole pair. This electron hole pair attracts the free electrons in the n type material. This will combine with the electron hole pair, forms a charge packet. So, this is how the charge collection is done. So, next we move on to the charge transfer in a CCD. How the charge is transferred in a CCD means we need to know there are many ways that how we are going to describe the charge transfer. Let it be like a 3 phase, 2 phase or n phase. If it is n phase means there will be n control wires, and each control wires are going to combine with each transfer clock. So, this is how it looks at. I am considering a 3 phase in each pixels. So, it is having a 3 gate. This is 1, 2, 3. 3 gates are there. This is one pixel and this is another gate, G1, G2, G3 of next pixel. This is G1, G1, G2, G3 of a first pixel. This is the first pixel, this is the second pixel. This is all the gates, having the all gates are connected to the gate 1 of first pixel and gate 1 of the second pixel are connected to phase 1. Similarly, gate 2 and the gate 2 of this both the pixels are connected to phase 2, and the same process continued. This is how the formation of the phase for a different things we are going to do. And here one more thing, the transfer clock will have a different phase, all the phase are different. The phase 1 is different from phase 2, phase 2 is different from phase 3, and also the voltage applied for this is also different. Why? Because by applying different voltage only we can control the heights of a potential well. Actually the first potential well will be higher compared to the next. Since we lower the potential well, the charges will easily move from the upper stream to lower stream, the first cell to next cell. This is how we are going to vary the heights of the potential well by varying the voltage. When the phase 1, look at the figure, in the phase 1 if it is low, phase 2 and phase 3 are high. So, these two are in a high, so the charge packets are collected here completely in this region. There is no charge packet in the phase 1, and this picture also shows clearly the charge from the phase 1, it is moved to the charge to the G2 under the this one it is moved to the second phase 2, it has moved, and here the charge are stored and it has to move to the next this one, this gate, under this gate G3, where it has moved to the G3 and it is stored here temporarily without losing any quantity or integrity of the charges. It has to store the electrons in the G3. So, after that once it reaches the maximum value, the charge again move to the next gate, that is G4. You can visualize the charge transfer like this, it is going to move and finally it will come out of the gate 1, again it moves to the next pixel. This is how the process of charge transfer continues to the one cell to another cell. Next we move on to bucket brigade device. This is another type of charge transfer. In the bucket brigade devices, there are capacitor, series capacitor and switches with FET switches. We know that FETs, that MOSFET having a gate that will exactly act as a capacitor. This concept is used in a bucket brigade devices. Here the structure of BBD looks like this. Every pixel have two switches will be there, this forms one capacitor, this forms another capacitor here, and the MOSFET drain of one pixel will act as a source of another one. This is a drain, this is a source S1, this drain, this source 1 will act as drain for the next phase, the next MOSFET. This is how the structure of a BBD looks like. This is the first MOSFET, this is the second MOSFET, this is the third MOSFET. So, drain 1, source 1, and this source 1 become drain 2 and this is become source 2. Then this will become drain to the next and this will become source. This is how the structure of BBD, and it is having switches and also series of capacitor. Concept that involved here is how the capacitors are going to charge. The capacitors are charged for a sample and hold, and the clock pulse is given at a particular time. So, at particular pulse, charged capacitor will going to charge the next freshly capacitor adjacent to it, and this is how the charging and discharging of the capacitor will takes place, that is the charge transfer. From the figure it is observed from the charge will flow from the left to right, always it is flow from the left to right, and the capacitance of the left will be more than the left switch or left capacitor will be more than the right one. At the T1 you observe the thing, the phase 1 which is lower and the phase 2 will be higher, where we are finding the charge higher and it is going to decrease in the right one. Again same thing happen from left, where the capacitor will be more, and when it comes to right it is decreasing. This is how the bucket brigade device. From the animation you can observe, you can analyze even better. This picture shows a bucket brigade analogy. As we say that bucket here we considered as a capacitor, and the photons as a rainwater falling on these buckets, the capacitors, and these capacitors or buckets are placed on a vertical conveyor, and there is a horizontal conveyor, and this is a metering station, that is the output amplifier. These all buckets, the vertical buckets will move like this and horizontal will move like this. For every movement of a vertical, first row will going to power the charges from first row to the horizontal conveyor belt, and this horizontal conveyor belt will power all the charges to the amplifier. This is how the analogy works. When the exposure is started, the very first exposure, the first row will power all the charges to the conveyor. Next, all the horizontal conveyor are filled, so all the buckets in the horizontal conveyor are powering the charges or rainwater to the measuring, that is the measuring tub or output amplifier. Again the second row will continue and it will going to power to the output amplifier. The last row buckets are powered. This is how the bucket brigade analogy. Next we move on to the applications. As I said, the CCDs are bucket brigade analogies are works with the digital photography and astronomy, sensors, electron microscopy, medical fluoroscopy, and optical and UV spectroscopy. These are the applications where we are going to use charge transfer devices. And also the devices where we can find these devices are astronomical telescope, scanners, barcode readers, machine vision for robots, optical character recognition. The summary that we know the charge transfer is by in a CCD is by varying the potential well heights, in turn vary the voltages. By varying the gate voltage we can vary the potential well. This pushes and pulls the charge packets from one cell to another. In a BBD, this is by charging the capacitor to sample and hold and giving a clock pulse to transfer the charge of a capacitor from one capacitor to another capacitor. These are the two things that we come to know from a CCD and bucket brigade analogy. The questions of this session: how does CCD works? What is BBD analogy? Does CCD or BBD contains any moving part? Further reading you can refer www.ccdsensor or answer.com, or you can read the book Electronic Devices and Circuit by G.K. Mittal. This ends the session. Thank you.